So are the slides visible and the voice audible?
Yes, sir.
Yes, sir.
Okay. So we start with the data flow testing. We have discussed a bit about it, but we'll refresh and recap the things. So it is a testing technique that revolves around the concept of the variables, how the variables have been declared in the program, and on which all lines of code the variables have been used. So we say it is based on the variables, their usage and their definitions, which is assignment in the given program. Uh, the name might look like that it is having some resemblance to the DFD, but it is not the case. It has nothing to do with the data flow diagrams. And the two main points that we normally consider in a data flow testing technique, which is a part of the structural testing technique, are: first is the statements where variable receive the values, that is what we call the definitions of those variables, and the statement where these variables are used, that is what we call the referenced. So two main part which we have to remember in this entire testing technique is the declaration of the variables, the initialization, and on which all lines of code in a program the variables are used. Now the primary purpose of designing and developing of such a technique is to just focus on the concept of the variable definition and the variable usage within a program. That's only the sole purpose of design and development of this testing technique is. And the variables are defined and used throughout the program. Hence, we can say this technique concentrates on how the variable is defined and used at the different lines of code within a program. That's what the main purpose or objective of understanding this testing technique and how to implement this testing technique is. But some of the common anomalies which we all find when we write a code within a programming language. Now, programming language again could be the programming language or the scripting language. So, depending on the two, we can have certain anomalies. Now, this is a common anomalies in the compiler-driven languages. That a variable is defined but never used or referenced. So, the compiler will keep on giving you the alert messages, warnings, and in some case the errors also. So variable is used but never defined, which is normally happen in the case of the scripting languages. A variable is defined twice before it used. Sometimes when you are developing a writing a code for a larger project, you tend to forget the so many number of variables you have declared. So it may happen that the same variable which declared once is defined twice, and the variable is used even before its first definition. So normally a case of the scripting language. And we have discussed one of the best solution to overcome this problem of the programming language and the scripting language is what we call the pods: one programming language, one operating system, one database, and one software as such. So that we don't have a problem of design and development of so many programming languages, so many operating systems, so many databases. It will be far things will be better if we have only one thing: one programming language, one operating system, and one database, so that the student or the professional just have to focus in one area. Just imagine a scenario where once the student has taken admission in the BTech first year, initially BTech first year is all focused on physics, chemistry, and maths only by and large across all the Indian universities. In all those universities where the change is allowed after first year. For example, there is a university where we got electrical, mechanical, civil, electronics, and computer science. So after the first year marks, the student is allowed to crisscross from one branch to another branch. So in that those universities, first year physics, chemistry, maths is always taught. But in just like triple ITs are there, where only the branch of specialization is computer science. So there they do not teach all these subjects right in the first semester because there is no cross discipline that will happen after the first year, because triple ITs are by and large focused only on the computer science disciplines. So in those areas, if we teach the student only one programming language in let's say second semester, databases in third semester, and the fourth semester operating system, and then he keeps on designing and developing a software for the next 2 years only in these three things: the programming language he has learned, the databases he has mastered. So by the time he comes out with the BTech degree, he will be proficient in that because every semester he has used that programming language and he has used the database for design and development of the for the solving a given problem statement. So normally when a fresh BTech enters into the industry, the common perception in the industry is that what you have learned. You have not learned anything, and your academics are not that good. We need to train you. So for the next 6 weeks, the company gives the training and almost the recap. 80 to 90% is the recap of the things we have already learned in the BTech. But now from the company's perspective, but the concept remains the same, the topic remains the same. But since in a BTech we really do not know where will the student land, in which job he will land in, whether he will do a coding in Java, or he will do a coding in C Sharp.net, or he will end up doing a coding in a mean stack. So in a BTech we train him in everything because we really do not know to what he will finally do. So we have to give him exposure of everything possible. But yes, if the BTech, the universities tie up with the industries in advance, that right from the day one, the student knows that yeah, this is my university, and this I'm after the BTech completion of it, I will go join this particular company. So there's a proper collaboration if it is there from between the academia and the industry. Then yes, student can be trained in a particular technology from day one. But in a scenario like India, where it's all haywire, it's all complex, it's all mix up, maybe chaos is the right word to say. We cannot just know where what will the student do. Maybe student after the BTech become a database administrator, so he will not use any of the programming languages, or maybe he becomes a cloud specialist afterwards. So what we as the teachers need to do, we need to design the whole BTech in such a manner that everything on the platter is offered to the student. Now it is for the student to decide what all he likes and what which online profession he will make a career with. So yes, day will be very good. I always, as a academician, I always believe that if we can train a student to only one technology, he will become a far better professional rather than asking him to do everything in every new semester. But then we require a lot of support for the academia, not only the academy but industry also, and especially the companies like Microsoft, Adobe, Amazon, Google, and IBM, because they send the trademarks, they send the benchmarks, and they decide which technology will be bright and in the years to come, which technology has to be pushed to for the students. So a lot of coordination is required, a lot of good friendship like spirit is required. Then only these things are possible. But till that, all these things, whatever is going on, we really can't stop from happening unless and until the academia and the industry collaborate with each other, and the students are given a placement right on the day one on such particular technology, and then his focus is clear that this is what I'm going to do in my BTech, and after that I will go join the industry and work on this particular technology on this training program. So in DFT, a program is first converted to program graph, which we have seen earlier also. Program graph has to be prepared, and which I think now everyone will be proficient in preparing a program graph. Should not be a problem. And in program graph, every statement of a program is replaced by a node, and the flow of control by a edge. So we all are familiar with that. Any graph will have the vertices and the edges. So here we say the statement of a program will be replaced by a node, what we call vertex, and the flow of the control by an edge. Between edge will, as we all familiar with, edge will always connect two nodes in a graph, and there could be a single path, there could be many paths in a given program graph. Now we need to come up with these two concepts of defined node and the usage node. Now try to understand it carefully how we do it, so that when we solve a problem, we should not do much of the problem in understanding of the concept. So we say defining a node. A node of a program graph is a defining node for a variable if and only if the value of the variable is defined in the statement, that is a line of code corresponding to that node in a program. So we're talking of defining a node, because first of all we need to go for definition and then the usage. And how do we represent it? We say DEF. D is for definition. Within parenthesis V comma N, where V is a variable and N is a node corresponding to the statement or a line of code in which it has been defined. So we're not talking of usage here, we're only talking of declaration and definition as such. Declaration we say char ch, definition we say char ch is equal to and some content of the string. So we initialize the string to some value, like int num1 declaration, int num1 is equal to 10 is the definition for it. You are assigning a value to a variable within a program. So simple example, let's say def str comma 4, where str is any variable and it has been defined on the line number 4 within a program. Now we are not talking of programming language here. The testing technique is designed in such a manner that it's actually implementable on the compiler driven languages rather than the scripting driven language, because in scripting languages we do not actually go for declaration. On the fly basis we can use the variable as and when we require to. So one of the common assumption will be in the entire DFT will be that it is a technique designed for the compiler driven languages. Now that was one definition for the declaration and definition of variable. This is the second part, the usage, how and where I use that particular variable within my program. So we say here a node of a program graph is a usage node for a variable if and only if the value of the variable is used in the statement corresponding to that particular node. So variable would have already been declared beforehand. Now we are going to use it. So that is what we are saying, the usage node. And how do we represent it? We say use in uppercase. The def is also written in the uppercase within parenthesis v comma n. Now just like in the def v was a variable, so here also v is a variable and n is a node corresponding to a line of code or a statement in which v is used. So similar concept to what it was there in the definition, but in definition we only talk of the definition, and here we talk of the usage. So def and use, there also v comma n, here also v comma n. There n was for the declaration and the definition, here n is for the usage of the particular variable within the program. A typical example could be use str comma 4. It's not a same variable, it's another variable. Any mathematical operation suppose is being performed on the particular line of code. So somewhere variable has been used. A point is I'm trying to raise, the variable has to be the show. It's somewhere programmer is trying to use that variable in his program. Maybe line number 4 or 14 or 24, or it could be any other line of the code in a program. Now we say there are two types of the usage node, because if you use a variable, there are two things what we can do with the variable within a program. First is either I use any of the looping constructs like if condition, while loop, do while loop, for, switch case. I use any of these looping constructs to manipulate those particular variables. And in those looping constructs, I can use any of the mathematical operations like addition, subtraction, multiplication, modulo, ternary operators, remainder. So any kind of the mathematical operations I might perform on those variables, or I can use a logical operation like a logical and or logical or a logical not. So that is one usage. Another is let's see the slide, because we'll discuss theory, then it will miss out the content in a slide. A usage node use vn is two things. First is a predicate node, which we say is a denoted as p and use. The p stand for the predicate and use is a usage node. Now this will happen if and only if the statement corresponding to the node n is a predicate statement. Now predicate statement means somewhere branching will take place based on decision making process will come into picture. So we say those nodes are the branching. So like if condition gets true, then this should happen, else if this should happen, else if, and then finally else and the and if. So we have a multiple branching that like in a flow chart, when we show it with the help of the diamond shaped box, where yes then this part should happen and then no then this branch should occur. So their decision making is coming, decision making coming in terms of the branching, either this will execute or this will execute. So those kind of the statement we say the predicate use node. Else we say it's a computation use node, where we perform certain mathematical operations, like we'll have the using any of the mathematical operators and or relational operator, any kind. Relational will not say, relational will come into the branching, so it will go into the predicate. But yes, any kind of logical operators. Logical again will have give you if condition will be used, so again it will go to the predicate. But we only come to the mathematical operators, because computation you are dealing with the variable, you are performing certain mathematical operation on the variable. So computation word itself says you are manipulating the contents of a variable. So predicate use knows wherever decision making comes if condition you need to hold true, switch case, multiple cases are there, switch if this, else case 1, case 2, case 3, case 4, and finally the default. So there also one of them will execute. If none of them hold, then default will execute. So those kind of the node will go as a predicate use node, and those where you perform the mathematical operations, they will go as a computation use node. So either we'll have the P use or as a C use. Now, after the def and the use, so we have discussed two kind of the node: definition, where declaration and definition take place, and the use, where we actually going to use it. And then there are two types of the use nodes: predicate use and the computation use node. Once the node have been identified, then we come to two kind of the path: the definition use path and the definition clear path. So first let us discuss the definition use path. It is denoted as du path for a variable v is a now this definition use path is a path between two nodes m and n, where m is the initial node in the path, but the defining node for the variable v denoted as v comma m. So it is a first node, the initial node, and the destination node will be denoted by n. So n is a final node in the path, but the usage node for the variable v. So we are using that node in that particular line of code. So how we will denote it as use v comma n. So we have source node where the variable will be declared and initialized, and then we'll have the line of code where this is the last usage of the particular variable. So that's what we call final node. So m is the initial node and n is the final node for that particular variable, from the point of declaration to the final point of the usage. So that is what we call as a path that exists between the source and the destination, the initial and the final line of code within which the variable is being dealt with. Then we have a definition clear path, what we call DC path. Now definition clear path denoted as DC path for the variable v is a du path, a definition use path with the initial and final nodes d, e, f, v comma n and use vn such that no other node in the path is a defining node for the variable v. So the statement itself says everything, otherwise we'll see the example how what does actually meaning it. So it's a path where we will have the initial node and the final node, and no other node in that entire path, let's say from the line number 4 to the line number 24, that would be a long path between the two nodes. So there's no other node in that path which is defining node for the variable v. So finally we are defining that node. I declare char str at line number 4, and then I use str at line number 24, and then I do not use str at any other line of the code. So this becomes my definition clear path from the line number 4 to the line number 24, declaration and then finally usage. And between that 20 lines of code, I have not used str any other place. So it's a clear path. No further redefinitions are existing of the same variable in that entire path. And after that also line number 24, if there's 50 line of code in a program, nowhere I am using the str. So that becomes a clear path. Whereas if I am talking of the DC path, it may happen that on the line number 24 and then the line number 48 and then the line number 39, I am using it multiple places. So in definition clear path,
Excuse me, sir.
yeah,
Sir, slide number 100 is visible, sir. The line you mentioned is not visible.
come again Pravesh, what you are saying, दोबारा बोलो एक बार.
अभी स्लाइड नंबर 100 विजिबल हो रहा है सर, जो आप प्रोग्राम मेंशन कर रहे
हाँ
हैं
हाँ,
विजिबल नहीं.
yeah, yes, that's okay, ठीक है, don't worry about that slide number. So definition clear path has to be clear path between the two ends. No further redefinition will exist, and if it exists, then we need to define it multiple number of the times. You will see an example to make it much more clear. So this should give you a broad difference between the two paths, the DC path and DU path. I want every one of you to read on your own if it is properly clear to you. So let me say it if you have read the first line. The DU and the DC path describe the flow of the data across program statements, across the line of code, from statements where values are defined to the statement where values are used. So we are defining both the paths have a common purpose, that they are going from declaration to the definition. So that's a common point between both this path, the DU and the DC path. Now, since du talks of the usage, so we are more focused upon the usage. So we'll have multiple times we can write the du path, because variable is being reinitialized or redefined multiple number of times within a single program, or the variable has been used multiple number of times within a single program. So we say a du path for the variable v may have many redefinitions of a variable. Many times the variable has been used within a single program between the initial nodes and the final nodes. So def u and the u comma n, and the def v comma n, and the final node use v comma n. So definition to usage. Whereas DC path is quite clear, here no ambiguity will arise. It's a direct one hop type of a situation where single path will exist between the declaration and the definition. So we do not talk of multiple redefinitions of the multiple reusage of the same variable. So your DC path for the variable v will not have any definition of a variable v between the initial node, that is def v comma n, and the final node, that is use v comma n. So in the du path, multiple redefinitions are bound to exist, but in DC path it's a clarity, so that's why we use the word clear. There will not be any multiple redefinition of the same variable. If you look at the third point, the du paths that are not definition clear path are therefore the potential troublesome path, because that can create a problem in the entire process, and they should be identified and tested on the topmost priority. But in definition clear path, we do not encounter any problems. It's all clear. It's a single path that is existing between the declaration to the usage. So DC path is quite clear, no ambiguities exist. But then DU path, yes, we need to keep a track of multiple lines of code where the variables have been uh, mathematically operated upon. It receives a value from the user, or it has been printable statement. So multiple number of times variable will be dealt with within a program.
So we have to take care, like only multiple redefinitions are not allowed, right? We can like we can have multiple usage of the variable v even in the DC path, but only the redefinition should be avoided, correct?
Come again, say again.
Uh, in DC path, like it is mentioned
Yes,
that there should be no redefinitions, right?
yes.
So only redefinition should not be there. Reusages can be there. The variable can be used a number of times, but only the definition part should not be there
Like,
multiple times, right?
what does that mean? That you use a final usage of the variable within a program is what we are concerned with. So
Mm-hmm.
from the line of code where it has been declared to the final usage of that variable within a program, we need
Mm-hmm.
to connect the two. We'll see an
Correct.
example. Don't worry about it.
Okay.
We'll see an example
Okay.
how to
Okay. Okay.
correlate the two. And we are not looking for the redefinition, the usage of the same variable multiple times of code. Don't worry. We'll have an example to give much more clarity.
Okay.
Now, when we do go for it, we'll have the multiple steps to be performed. So we have four steps which we need to do. First step, we draw a program graph, which I hope everyone is now comfortable and convenient with, and will be able to draw without much of a problem. Then we identify all the variables of a program and prepare a table. Now this preparation of table is important in this entire process. For define or the use status, so means identifying those line of code where the variables is defined, and identifying those line of code where the variable is used for all the variables. And we have a predefined format of the table, something like this. First column contains serial number, second column contains the variables, third column contains the line of code in which variable is defined, and the fourth column contains the line of the code where the variable is used. So let us say we have got a variable called num1. We give the name of the variable as num1. We define at line number 4, and then use at line number 12. And it can happen with multiple ways. So there could be many variables within a program. We have to list all those variables within this table, identifying their definition and as identifying their usage. And we need to identify the line number on which they have been declared and used. That is the second step we need to do for the identification of the DU and the DC path for a given program graph. Third step, we
We are
just
talking about, sir, we are talking about the first uses or the last uses of the variable in the fourth column.
let us take an example, and then we'll take queries after that. Okay, because the
Okay,
example
sir.
itself is very good and self-explanatory. I don't think so there will be any question left after that.
Okay.
Now, third step, generate all DU paths from defined or the usage variable. table of the step 2, and we use the following format. So we use serial number, the variable, and we give the du path to begin and the end. The line of code where it has been started with the begin part, and from the line of code where we are going to end with. So we say du path within parentheses begin comma end, and we identify those du paths which are not DC paths, means which are not definition clear. So we only focus on try to identify those du paths which are not the definition clear path, and we'll see an example how to identify it and how to come to step number. And after finding this path, test cases are generated by giving the values to the input parameters. So multiple programs, every program will have certain input parameter. We have seen in the last class also when we did mutation testing. So we'll take the same program and apply the data flow testing over it. So we give the variable input A, B, C, and we have introduced the mutants M1, M2, M3, and M4 within a program. And then we draw 4 tables because 4 mutants were introduced. So M1, M2, M3, and M4, and we give the input parameters A, B, C to find out the largest of the 3 numbers. And then we have the last 2 columns as expected value, EO, and the actual output. The expected output and the actual output, EO and AO. So we were able to identify. And then we computed the mutation score, where it's a number of the killed mutant divided total number of the mutants. So same program will carry forward the data flow testing, and then we'll get the input parameters to find out the values which are going to be as the output values. So if you catch the same program, it's also given on the search book on the, we can look have the page number. So 176 the program has been given. It's the same Professor Yogesh sir's book. So I hope we have been able to lay our hands on the hard copy or the soft copy of it, because that becomes easy and it's easy to go through the contents of the book and also prepare for the exam. We are going to notify the date sheet probably tomorrow or day after. So we'll have the exam in the month of October. So make sure we are able to cope up with the things, all the subjects which we have got at our disposal. We are gradually preparing for all the 3 subjects. So we consider the program graph to find out the largest among 3 numbers, and we perform the following task one by one. So if any problem statement is given to you in the program, we have to perform the following steps. First is we write the source code of a program. Now, preferably we write the source code in the compiler-based languages only, because we are dealing with the variables. So we use C, C++, Java, C#, Kotlin, any of the programming language you can use. You can Go or Ruby, and whatever you want comfortable with, use it. But we write the source code of a program. Then second step, we generate the program graph, because then only we come to the definition, def and the use, and thereafter we'll find out which is the predicate and the computation node, and thereafter we can identify which is a du and the dc path. Same concept, there are 3 variables in a program, namely a, b, and c. So we identify defined node and the usage node for all these 3 variables in a given program, and we identify the DC and the DU path. So these are the steps that need to be performed sequentially one by one. Write the source code, generate the program graph, identify the defined node, identify the usage node, then identify of the usage node which are the predicate node and which is the computation node. Having done that, we identify the DU path and the DC path. That's a sequentially all these things need to be performed. So I'm sharing the doc file in which I have the program. So I will mail this doc file to you also. So you can also go through it at your own end, and it will be easy for you to understand the concepts. So I hope it is visible to all. A quick yes or no?
Yes, sir.
Fine. So before we start using program graph, we have certain more graphical symbols which we use in a program graph, which we have not used till now. So let's have a quick review of the various graphical concepts in the notation available in the program graph, so that we can apply by a given problem statement when we are writing a code for a given problem statement. Definition is all simple and very clear. Program graph is a directed graph in which nodes are either statements or the fragment of a statement, and edges all represent the flow of a control within a program. A simple broad definition of the program graph. And a good program graph is one which will help us to understand the internal structure of the program and which can provide the basis for designing the testing technique, because almost if you look at many of the testing techniques, almost the entire structural testing technique paradigm of the slice based testing or the data flow testing or the mutation testing or the control flow testing, they all are built around the concept of the program graph. And some of the basic concepts which we use for the program graph: node is all clear, should not be a problem. Then edge is all clear. Then from a single node, we can have two outgoing edges when we do the branching, and there could be more than two edges. So two outgoing edges can be also be there. So we can represent it. Then a sequence of statements within a program. There could be sequential sequence of statement. I can club together to create a single node to represent many statements together. We can have a junction node where control flow joins after the branching is successfully been done. We can have a decision nodes where I can have the if then else statement representation within a program. So that is also equally possible. We can have the while loop kind of scenario within our code. So I can have a node. This is how it looks like, and then you simulate same while loop has represented with the help of the nodes in a graph. Or we can have a repeat until, which will simulate those branching within a code on the program graph. Or we can have the switch case representation. So these are multiple graphical notation which are available for us within a program graph, and then when we are drawing a program graph, we can use any one of them depending on the line of codes written within a program. Now we come to a problem statement of data flow testing, that is objective to determine the largest of the three numbers. I'm closing down a session and then I'm restarting the session again because the time limit has elapsed. Okay. Is it visible? Quick yes or no?
Yes, sir.
Yes, sir.
So we were data flow testing. We start from the same place again. So program is same what we did for mutation testing. So I think code is already comfortable and convenient to all. First of all, things to remember: in the header files we don't give the line number, so no line number are given. Then we start with line number 1. We define a main function. Opening curly braces, we declare three variable a, b, c. Clear screen. Printf, enter the first number. We receive the input using a scanf function. Then printf, enter the second number. Then we receive the input using a scanf function. Then third number, we receive as the input in the line number 10. So in the line number 1 to 10, if you see, everything is very sequential in nature. So what we can do, the program graph gives us a choice. I can merge all of them and represent by using a single node. That also we can do within a program graph. Or let us write each and every node for representing each and every line of code within a program. Then we check of the greatest of the three numbers. So if A is greater than B, if A is greater than C, then we say print the largest of those three numbers.
Sir, excuse me, your voice is not clearly audible.
Is it now better? So let's speak much more
The
louder.
volume level is low.
Low, yes.
Better than before? I hope so.
Yes.
Okay. So if we will come to line number 14, line number 15, we say else printf the largest of the three numbers is this. B, C, we had printed line number 16, then 17, 18, closing curly braces. Else if C is greater than B, then print the largest of the three number is C. Else the largest of the three number is B, and then we close down the line number 25, 26, and 27 is a get case. So we solve in a given problem statement. Only thing is, remember, you write any kind of the code that depends upon your logic. Make sure to give a line number to each and every line of code within a program. That is most important. And we do not give line number to the header file. That is two things we need to take care of. Logic is all yours. You can write the way you want it. No problem regarding that. Now, once the code has been done, second thing is to draw the program graph properly, because all your further things down the line now depends upon this program graph. So define node, usage node, then identification of the usage and the computation node, and further the identification of DU and DC path. Now all depends upon the program graph. So here line number 1 to 10 is all flat sequential in nature, so we can all see they are continuously connected to each other. Now line number 11 is a predicate node, because if you look at the code written in the line number 11, we are doing a checking. If A is greater than B, so condition is being checked. Decision is going to be made. So line number 11 is a predicate. Now, depending on the line number 11, either the branch of this will execute 12, 13, 15, 14, 16, or the second part, the branch will execute 19, 20, 21, and 22. Then more if conditions are there, more code are there. Finally, it will converge to the line number 27 after everything is being done. Here also after 20, either we take a track of 21, 22, and 26, or 23, 24, and 25, where every of these numbers represent a line of code within a program. So your code will now be mapped to a program graph. Finally converging to the line number 27, and then closing the program down on the line number 28. Final termination is more like a start and the stop. This is the stop of the just like what we write a flow chart for the program graph, where everything comes to stand. So the same program graph which we have seen and discussed earlier. Now what we will do furthermore in this, what our objective is, that we try to identify the variables and the defined node and the use of which all line of the code within a program. So if you look, we have got three variables here, variable A, B, and C. Now first thing what we need to do, we need to identify the line on which they are defined. So if you look, third column defined at node, A is defined at 6, B at 8, C at 10. So if you look here in the program, 6 where we receive the input from the user, 8 where we receive the input from the user, and 10 where we receive the input from the user. So 6, 8, and 10 are. That gives us a third column. Now fourth column expects us to identify that on which all line of code we are using that particular variable. So use at node. So we say line number 11, 12, and 13. Now we look at the journey of the variable A, and we say here line number 11, 12, and 13. And thereafter we have not used anywhere the variable A, right? So when we are drawing this table, so we identify a variable, we give the point line of code where it has been defined, and on which all lines of code it has been used. So use at 11, 12, and 13. Let us say for the variable B also, defined we have already seen scanf, so at line number 8, and we say use at line number 11, 20, and 24. So we just check the line number 11, it's already there, B, then we come to the 20, C, and then 24, printing of it. So these are three lines of code where the variable B has been dealt with in a program, maybe for printing, maybe for decision making. And same goes for the journey of the variable C, defined at node and then used at node. That's the first thing we need to do. Now, if your program graph is correct and is mapping to the lines of code correctly, then we will be able to reduce this table fine. If your program graph is not mapping to your source code correctly, then we'll have a problem in mismatching of this line number of code or usage. So we need to make sure the proper mapping is successfully done. Now we come to the DU paths. So we said DU path is the beginning node and the end node. So we are given as, now if you look at the variable A, there are all three variables A, B, and C. So we identify the du path firstly for the variable a. Now we know du path has got two parameters within parentheses, begin and the end. So if you look here, if you have properly drawn the first table, 6, comma 11, 6, comma 12, 6, comma 30. So now if you look at this du path 6, 11, 6, 12 and 6, 30. Because these what is the 6 common? The first line, the 6 is the line number of where we have input, we have received the input from the user using scanf function. 11, 12 and 13 are the lines of code where they have been used. So du path is the begin and the end, 6, 11, 6, 12, 6, 13. Then same way, if you have drawn this table correctly, we come for the variable b, defined at node 8, used at 8, comma 11, 8, comma 20, 8, comma 20. So if you look here, 8, comma 11, 8, comma 20, 8, comma 20. So these are all our du path, and du path can always be multiple because single variable can always be used as multiple line of code within a program. Now we look at the variable c. Again, there are 4 lines of code where it has been used. So 10, comma 11, 10, comma 16, 10, comma 20, and 10, comma 21. Now if you look at this variable c here in this table for du path, 10, 12, 10, 16, 10, 20, and 10, 20. So two tables we have drawn till now after the completion of program graph. First is wherein we identify third and fourth column, defined node column and the used node column. That is very important that we should draw this correctly. We should prepare this table correctly. Having done that, we come to du and dc path. First, we identify the du path. So du path here is a multiple lines of code because the variables has been dealt with. So we identify multiple lines of code and then we draw du path. Begin. Not to draw, but we identify the du path. 6, 11, 6, 12, 6, 13, 8, 11, 8, 20, 8, 24, and C 10, 12, 10, 16, 10, 28, 20, 21. Now, let's look at the strategies, multiple strategies, how we can do it. So we have first strategy to test all the du paths, whether they have been identified correctly or not. Second strategy is to test all these paths which have been identified. And third is to test the definition of all these paths which have been identified. So du path as per these three strategies, let us see. Now here we identify whether the path is the definition clear path or not. Now this thing should be easy to understand, but because it has to be marked in Boolean yes or no. So here, if you look at the very first column, all the du paths and all the uses, both are in the same example only. Both we have the largest of the three numbers. Now we have identified three du paths for the variable a. That was 611, 612, 613. Now from the line number 6 to the line number 11, is the path all clear? We say yes, it's all clear. There is no further problem in here. Now in the line number 6 to 12, is the definition clear? We say yes, it is clear. In the 6 to 13, it is clear. We say definition is clear. There is no ambiguity in the definition as such. The variable has been properly dealt with. Now our this for the variable 6, 6 to 13 should be the first and last. So we need to remember that when we will be giving a definition here, the first node here and the last node here should match here, the line number here and the line number here. These are small things you need to remember when identifying the definition clear path. So 611 yes, 612 yes, 613 yes. Then we come to 811, it is definition clear, we say yes. 11, 19, 20, we say yes. 11, 19, 20, 23 and 24, it is all yes. Now, the first definition is at line number 8. The first usage is the line number 8 and the last usage is the line number 24. The first and the last is the initial and the final destination. Then we say 10, 12, yes. 10, 12, 15, 16, definition clear, it is yes. 10, 11, 19, 20. If you properly identified, yes will come. I don't do any big deal in going through again and again. 10, 11, 19, 20 is all yes. 10, 11, 19, 21 and it's all yes only. Now we look for all the definitions. Between 6 to 11, if all the definitions are clear, we say yes. 8 to 11, again it is yes. 10 to 12, it's all yes. No ambiguity anywhere. We can identify directly that yes, from the line number 6 to line number 11, all the definitions are clear to us, no ambiguity is there. 8 to 11 also it is all clear. Then 10 to 12, 10 to 12 if you look for the variable C. So 6 to 11 for the A, 8 to 11 for B, and 10 to 12 for the C. So they are all clear to us without any problem. Now, so here we can say all DU paths and all use paths are the same, and there are 10 DU paths which have been identified. So if you do a count of it, they will give you the 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and the 10. 10 all DU paths have been identified, and all of them are the definition here. There are no ambiguity in here. So you can say yes for all of them.
Sir,
Yeah,
sir, may you please repeat this table again? Because I'm not able to understand this.
I will share you this file.
Okay, sir.
No problem regarding that. I will so that you can have it. Or if there's a in the book also, if you have got your book, you can see the examples from that. It should not be any problem.
Sir, here in the table, how have we taken the paths? For example, there is one path 8 to 11 and then 19, 20, 23, 24.
Hmm.
How have we taken this path? How did this 19 came into picture?
If you look at the line number 19, it's still going on.
Haha,
It is still checking the part of it.
right.
If we from the line number 8 to the last line where the variable has been used in that scenario. For example, if you look at this, let me come to that. Uh, Starting from 8 to the final reaches of the line number 20, 11 and 19 have also been used to reach up to line number 20. Same way for culminating at line number 24, the lines of code written in the 11, 19, 20 and 23 have also been used. And then finally the usage of the variable gets over at line number 24. So journey goes from 8 to the 24. That's how we have been able to say it's a yes.
Okay, and for the second last, it's simple separated by commas. So 10 is individual, 11 is individual, 19 is individual, 20
Yes.
is individual. What they are depicting?
Which one? 10, 11, 19, 20.
Yes, yes,
All those lines of code, if for the variable C, if you look at this 10, 11, 19 and 20, 10 you are receiving an input for C.
right.
What was the next line? 10, 11, 19, 20.
Yes, and then 11, it's a if statement where it is comparing A is greater than B. How did that came into picture?
10, 11, 19, we are dealing at C. 10, 11,
Okay,
19, 20. So 19 goes, now this to enter into the else part, we need the line number 19 also because we are printing for the variable C. So 19, and this is the else 10 we are expecting as an input. Now we say if A is greater than B, then do this. Else what will happen? It will come to the line number 19. Are you able to understand? If
okay.
first we check here, if this becomes
Mm-hmm.
true, we go to line number 12. If this
Right.
goes as a false, we come at line number 19, then 20, and then 21. So that's how 10, 11, 11, 10, then 11, then 19, and 20, and the 21. 10 you receive as the input, 11 you do a comparison, and then the else part of this will happen here. We can ignore it because we are not dealing with it. We're only concerned with the variable C here. And again, the C has been act into picture after the line number 19. So 19, 20, and 21. That is how we've taken it.
It will be taken only for the else part,
Yes,
not for the true.
true is within, wait,
That is on 12 itself.
Sir, should we follow program graph?
program graph is actual representation of your source code only. What else is a program graph? Uh,
I mean the usage, the sequence that we are taking here, like 11 is coming after 12, so we are taking both of it in order to check C.
uh, Let me see it again. 10, 12 is okay. 10, 12, 15, 16 is okay. 10, 11, 19, 20, 10, 11, 19, 20. Let us see this last two. They are something
Yes, sir.
need to be checked again. Instead 11 should come or 12 should come. That is because in 11 we are dealing with A and B. 11 we are dealing with A and B.
Right.
Let us see these two lines of code. 10, 11, 19, 20 and 11, 19 to 21. Let us check it. 10, 11. Okay, this comes here 19, 20, 21.
Sir, does the dash line, the dash that is present there, doesn't it represent that all the numbers between it are using, like when it is given that 6-11, then we have to go follow the path 6, 7, 8, 9, 10, 11, like that.
Of course, when you say 8-11, that means 8, 9, 10, 11. Here 10 to 12 means 10, 11, 12. Here again with 10, 12, and then 15, 16. Now we cannot include 13 in it. We cannot include, same way we cannot include 12 here. Wherever dash is there, that is very clear. 10, 11, 12. 10, 11, 12. 8, 9, 10, 11. But here we say 10, 11, and then 19, 20, 21. So dash is 5 points, we should not be enabled. For example, we say 6 dash 11, 6, 7, 8, 9, 10, 11. That should be clear. So कोई ambiguity नहीं. Only point is the 11 need to be checked. Why 11 they are showing it with because we are dealing with the variable c, and variable c has not been used in the line number 11. That is something.
And sir, why we have two separate paths, like one we made for 10, 11, 19, 20, and then 10, 11, 19 to 21? Oh, can't we combine it into one only?
We can
Because we are looking at.
we can combine that.
Okay.
The table need is our perception how we prepare the table. Table should be clear. Table should not give us any ambiguity. That is something that we do.
Okay.
So the only point of contention here is line number 11.
Right, because he is not used here.
So we leave it at that. There is no point in continuously wasting on time of these lines. It logically speaking, it should be 12 because we are not dealing with them, but still we'll cross check and then I will.
Maybe it's working for the false statement when the condition becomes false.
I don't want to make any statement on that unless and until the facts are verified. Anyway, let's move forward rather than wasting our time on it. This is all clear, all definitions 6 to 11, 8 to 11, 10 to 12 for the variables A, B, and C. So leaving alone these two lines, which look a bit ambiguous. Otherwise, all on the top it is all clear. For 10 paths, leaving alone these two paths, where line number 11 is something that needs to be cross-checked. Whether it should be 11 or 12, rest all is fine. Now we'll have a look at the test cases, how we can design. It is something like what we did for mutation testing also. We draw a table. So we'll identify all the inputs for the variable A, B, and C, and fourth and the fourth column is expected output. Same was there in the mutation testing EU, and then last column was actual output AO. Now here, instead of actual output, we see the remarks, which we need to identify for testing of all the DU paths. So we give the input to the variables A, B, and C, 9, 8, and 7. Expected output is all 9. That's fine. Now, on which one line of code it will happen? We say line number 6 to 11. So we know line number 6 to 11 are dealing with the variable A. We have seen this. 6 is starting from this place, scanf, and then finally we say 6, 7, 8, 9, 10, and the 11. This is the branching happens if A is greater than B. So remarks which are given for dealing with this variable 9, 6 to 11. Then again 9, 8, 7 goes as an input. Same repetition. If you look at all the three lines of code, expected output is 9, 9, and 9. And there are three ways how we can represent it for declaration of variable between the line number 6 to 11, between the line number 6 to 12, and between the line number 6 to 13. That will give us the output A. When the input is given as 9 for a variable A, it will give us the output 9, 9, and 9, and the line number 6 to 11, 6 to 12, and 6 to 13. So 6 to 11, 6 to 12, and then 6 to 13. So in these three, we deal with the variable A.
सर मतलब इनका इंडिविजुअल पार्ट है या फिर ये कंबाइंड है, क्योंकि 6 to 11 में तो सिर्फ एक ही कंडीशन चेक हो रही है ना?
नहीं, फिर सब वेरिएबल्स के लिए अलग से बनाया गया है. देखो अब 9 जो इनपुट पैरामीटर्स हैं आपके 9, 8, 7 तीनों के लिए है तो तीनों की वैल्यू सेम, पर तीनों 6 to 11 एक बार चेक किया हमने, 6 to 12 में दोबारा किया, 6 to 13 में कंप्लीट हो गया. मतलब मैक्सिमम जो लाइफ है उस वेरिएबल की फ्रॉम स्टार्टिंग टू द एंड इज बिटवीन 6 to the 13 only, the journey time. Let's look.
अच्छा, ये एक ही इनपुट का पार्ट है।
Yes, एक इनपुट है। अब मैं एक इनपुट
ओके।
सेकंड, अब 4th 5th 6th में भी आप देखो एक ही इनपुट पैरामीटर्स है 7898 798 एंड 798। थर्ड में भी सेम ही है 879 879, लास्ट में जाके दो चेंज किए 789। अदरवाइज दे यूज द सेम इनपुट पैरामीटर्स, पर वो अलग करे हैं 789 तो इसलिए अलग रिमार्क्स भी आ गए। 1 2 3 में सेम है, उसमें कहीं कोई चेंज नहीं है, तो 987 987 है 987। 4 5 6 में वेरिएबल बी के लिए वैल्यू 9 है, तो 798 798 एंड 798, एंड वी नो द एक्सपेक्टेड आउटपुट विल बी 9। नाउ द लाइन नंबर ऑफ द कोड फ्रॉम वेयर इट विल डेल्ट विद 8 to 11 first time, then 8 11 19 20, then 8 11 19 20 23 and the 24, the last line where the variable b will be printed as the output to the user. So 8 to 11 11 19 20 and 11 19 20 and 23 and 24. So if you look at this 8 11 8 and the 11, then 19 20 21 23 and 24. So you identify all those lines of code जिन तक पहुंचने के लिए वी आर यूजिंग देयर इंटरमीडिएट लाइंस ऑफ कोड, एंड फाइनली इट शुड टर्मिनेट इन द प्रिंटिंग ऑफ दैट आउटपुट टू द यूजर, बिकॉज उसके बाद फिर बी यूज नहीं होगा। So this should be line of code, line number 24, where we are dealing with the variable b, and all the intermediate line of code will also come into picture, जिसके थ्रू हम b तक पहुंच रहे हैं। So if we are dealing with the output as the 9 आ रहा है, तो 8 to 11 में, फिर 8 11 19 20 में, फिर 8 11 19 20 23 एंड 24 द लास्ट लाइन ऑफ कोड, जहाँ पे हम आउटपुट दिखाएंगे बी का एज अ 9। सेम वे अगर हम सी का देखें 879 879 10 to 12 के बीच में, और 10 12 15 16, तो 10 to 12 10 में तो इनपुट ही आ गया, और 12 में हमने कंडीशन चेक करी, एंड देन प्रिंटिंग हमने कराई 15 और 16 के अंदर। So 10 12 and 10 12 15 16. So same thing has been represented here using the test cases table 10 12 or 10 12 15 and the 16. If you see the two more ninth number और 10th number पे 789 इसमें इनपुट चेंज कर दिया गया वेरिएबल सी, मेरे पास दोनों 9 हाईएस्ट है, बस ए और बी की स्वैपिंग हो गई है। So we need to go for the line number जहाँ पे C का output is 9 and that get printed to the user because this is the greatest of the three numbers. So 10 11 19 20 and 10 11 19 to 21. So we can cross check it here 10 11 10 11 we know, it's all simple, then 19 and 20 जहाँ पे हमने C वेरिएबल की आउटपुट प्रिंटिंग कराया। आफ्टर द ब्रांचिंग ऑफ इट एल स्क्वायर और एल स्क्वायर में C से B को कंपेयर करा, and if C is greater than B, then the largest of the three number becomes at C. Now कितने नंबर हमें टेस्ट केस डिजाइन करने पड़ेंगे इस टेस्ट टेबल के अंदर? इट शुड मैच to the number of DU paths which you identify here. Now here you have identified 10. So 10 test cases also need to be designed that, because here यहाँ पे जितने paths हैं आपके पास 1 2 3 4 5 6 7 8 9 10, so all these 10 DU paths need to be further dealt with, and उनके लिए टेस्ट केस डिजाइन करने होंगे हमें टेस्ट केस टेबल के अंदर, जहाँ पे मल्टीपल आप कॉम्बिनेशन ऑफ इनपुट वैल्यूज दे सकते हैं टू गेट द एक्सपेक्टेड आउटपुट। Now let's see another example. It should make the things much more clear. This is a sample program graph. If you look at this program graph, the first is a node, so we define it. So a variable is being defined at the line number 1. So it is being represented by 1. Then we come to 2. 2 के बाद branching हो गई, either we move to the left hand side or to move to the right hand side depending on if and else. So 3 4 and 5 we reach to the 6, and via the else part we come to the 6. So in both the cases are perfectly possible because the sample program which has been taken into picture. Then we come to the usage. How we are using that particular variable which has been declared at the line number 1. Now 6 के बाद branching है, Either we go to this path of 7, 8, or we go to the track of 9 and 10, and then finally converging or closing on everything in line number 11. Now, the variable a has been used at the line number 7. So, how do we write the use within parentheses a comma 7? And then the variable b has been used at line number 8, so use b comma 8. So, once we define a program graph, it is also advisable that you write this line within the program graph. So what are the defined node and what are the usage node? Same way here, use b comma 9 on the line number 9 and use a comma 10 for the line number 10, because at line number 7 and line number 10 the variable a has been used, and same way line number 8 and the line number 9 the variable b has been used. So within a program graph we declare that is the defined node and the usage node, and which becomes the predicate node here, the node number 6. So we can write here predicate node also. So this is a defined use node table for a given program graph. Now here first thing you need to draw the table before we go for identifying the path. So there are only two variables a and b. First thing, we define them at the node. So node is 1 here. Both of them have been defined as the node 1. So we define the table here, define node table, and they have been used on the line number 7, 10, 8, 9. So a has been used on 7, 10, b has been used on 8 and 9. First thing, our defined use node table is simple. It should not be a problem to anyone in drawing it. First column serial number, second column is the name of all the variables. Third column is the name line of code where the variable has been defined, and fourth is a line of code where the variable has been used. So 7, 10 and the 8, 9. Now we identify the DU path. This should not be a problem. This is again simple because this is the second table we draw. First column is serial number, second column is variables, third column is the DU paths. So we say begin and the end. कहाँ से शुरू करके कहाँ पे खत्म करना है. So variable A, if you see 1 to 7, then variable B 1 to 10, because if you are using this path for the variable A, so 1 becomes the initial node, 7 becomes the final node. If it comes to this path after branching, so 1 comma 10, so either it takes the path of 1 comma 7 begin and then, or it goes to the path of 1 comma 10. Similarly, we go for the variable B. It takes the path of 1 comma 8 or it takes the path of 1 comma 9, the begin and the end. So again, this table should not be a problem for anyone dealing with a question which we will just do after that, after discussing this example exercise. So this table should not be a problem, the defined use table. The DU path table should not be a problem. Problem can come in these further things, the DU paths which are identified as per the testing strategy. Now here we identify all DU paths which are 8 paths. So 1, 2, 3, 4, 1 dash 4, 6, 7. So is the definition clear? We say yes, because the variable has been dealt with. If you look at this path 1, 4, 6, 7, 1 here, 4, 6 and the 7. Because if this is true, then only we will come via this path. So 1, 4, 6, 7, that is what they are representing here. Then 1, 2 and then 5, 7. So if you look at this line of 4, 1, 2, else we move towards this path, 5 and then coming to the 6 and then 7. So either you take via this path and then close it down at this for usage of the variable. So 1, 2, 5 to 7, then similarly 1 to 4, 6, 9, 7, 6, 9, 10, then 1, 2, 5, 6, 9, 10, 1, 4, 6, 7, 8, then 1, 4, 6, 7 again, 1, 2, 5, 2, 8, 1, 4, 6, 2, 9, and then 1, 2, 5, 6, 9. So these are the different DU path defined use paths which we identify from a given program statement. So our starting line of code was 1. So we just need to remember everything should start from 1 here, and then finally last line where that variable has been finally been dealt with उस particular path के अंदर, because multiple paths are being identified from the single line of code. Either we can take the path from 1 to 7 or 1, 2, 5, 6, 7. So definition should be clear for the particular variable in that particular path. Now here they have identified 8 paths. You can even identify 4 paths because they will also be able to cover the entire program graph. Same way, all uses, where you can give a definition of this usage path, all uses and all definition. So 1467 is this only. The first one is the definition clear. Yes, it is clear, no problem. Then 124697, third one. 14697 is the definition clear, fine. Then same 124628. 1 to 4 and 6 to 8. So it's all definition is all clear. So there is no hard and fast rule that we need to identify 8 or 15 or 20 paths, but yes, all the paths should be, the program should be well covered. No branches should be left out. The coverage should be as wide as possible, and every single variable which you have having in your program should be dealt with. But there's no upper limit or the lower limit that these are the number of paths you should identify. But yes, all DU paths should be able to cover all the possible branches within a program. It should not be, no node should be left untouched. Means my path is not touching that node, that kind of situation should not happen. Your path should be able to cover and crisscross and navigate across all the nodes within a program. That is something what we need to take care of. So 4 tables need to be drawn after the completion of program graph. First is the defined use table, which should be simple to understand with. Second is a DU path table where we identify the begin and the end part of it. And third is a DU path table or rather DC path table also where we give the definition here. If it is yes or no. By and large, I haven't come across any program where they give the definition as no. If you have identified the path correctly, the definition will come yes or no. So there should not be any ambiguity in the definition here also. And you will be able to identify the proper path because you have only written the source code, you have only drawn the program graph, and you are only yourself identifying the path. So all the paths in the, by and large, there's all the definitions, so there should not be a problem. Now let's do a sample exercise and do all the steps one by one. Consider a program graph for the determination of the division problem. Its input is a triple of the positive integer marks 1, marks 2, marks 3, and the values for each of these may be from the interval 0 to 100. So the marks are going to be input from the subjects, 3 subjects from the for a student, and the teacher is going to fill these marks for 3 subjects, marks 1, marks 2, and marks 3. Again, the range will be from 0 to 100, and the output may have one of the options given below. So let's look at the option: pass, fail, first division, second division, fail, third division, second division, first division. These are the possible outputs. Now the first division with the distinction. So there are 5 possible outputs of the marks a student can score for 3 particular subjects. And there could be invalid marks if the teacher might have entered incorrectly. Now what we need to do, first of all, identify all DU paths and identify all DU paths, the definition here. So if you identify DU path, the last statement will always come, remarks, definition here, answer will be yes. Do not worry about it. Also find all DU paths, all uses and all definitions where, so we need to identify all those lines of code where proper paths are there. So first, let's say 1 to 4, then 1 to 4, 6, 7, then 1 to 4, 6 to 10. And we generate the test cases for all these particular paths. So sequentially what we need to do, first of all, we write a source code, draw a program graph. Third is we draw a table called defined use table. Then we identify a DU path table where we cover the begin and the end. And thereafter we come to this DU, the DC path, whether there is a definition clear or not. So let us see the source code. Is a doc file visible?
Yes, sir.
Yes, sir.
So it's the same program code to find out the output division of a subject based on the marks in 3 subjects. So again, the header files are not numbered. So we start the lines of code from the line number 1. So we come to the void main function. Then we open the curly braces. We declare the variables int mark1, mark2, mark3, and the average. So when we say define, these are the line of the code where the variables are defined, line number 3. Then clear screen, we prompt to enter the marks of three subjects to the valid values between 0 to 100. So if you print enter the marks of first subject, so the input person n1 mark 1, so we receive the value and store in the variable mark 1. Then we receive the input and store the value in the mark 2, and then we receive the input and store the value into the mark 3 variable. So three variables have been input and they're stored here. Now we carry out a check if mark 1 greater than 100 or mark 1 less than 0 or mark 2 greater than 100 or mark 2 less than 0 or mark 3 greater than 100 or mark 2 less than 0. So invalid marks for all the three cases wherever the value is either less than 0 or more than 100. This becomes a common condition for all the mark 1, mark 2 and mark 3 variables. So in line number 14 we have only checked, we have received the input and find out whether the input is valid or not. So line number 12, the branching is happening for the first time. So if condition is come, that means it will have a predicate node. Now if this holds true, we do the printing, else we come to the else part and we carry out to the average. So average equal to mark 1 plus mark 2 plus mark 3 divided by 3 because there's 2 subjects. Now this line number 16 will be called as our usage node. Computation use node. That was a predicate use node. This is a predicate use node, line number 12, where you are doing a comparison. And this is a computation use node where we are applying a mathematical operator on a variable. Now again, this becomes a predicate node. If average is less than 40, we say printf state. However, if the average is greater than or equal to 40 and less than 50, we say printf the third division. So line number 22 closes as we come to the else if average is greater than or equal to 50 and average less than 60, we say printf the second division. Else if average is greater than or equal to 60 and average less than 75, we print the first division. And then finally culminate at the else, print first division with distinction. Now these are the nodes line number 31 and 32 where converging will happen depending on different paths you have taken it down. So there are two curly braces because the if condition is getting closed down. First is for the closure of the else, the line number 31, and then the closure of the initial if we have taken at the line number 32. Then finally get ch and then closing down of the main function because the main function is the function which is being running here. So closing down of the line number 34 is the main function. So I'm sharing this program code. What I want every one of you now draw the program graph for it because we have seen the program graph and it should not be a problem. So I'm sharing the source code. We'll take a break for 15 minutes and I think that is a good much amount of time to draw the program graph. In the chat box I have shared the entire code. You can copy it from that and then copy it nicely that you don't jumble it up. All the line number are coming properly in the chat box. So you can copy the same program from the chat box and then using the source code as a base, draw a program graph and thereafter draw the table where we carry out the identify the nodes and identify their declaration and the usage part. That means what I'm trying to say here is we should be able to do, if you look at the earlier program, in the earlier program graph has been drawn. This is what is expected from you. Do it. You should. I think everyone should be able to do it because source code is there. Then we draw this table where we have got third and fourth column is define that node and use that node. We should be able to do it. The DU path should also be identified because they begin and the end. That should also be done. It becomes easy. And then you identify as many paths as possible here, which are all definition clear. That is left to the actual source code and how you draw a program. It should be perfectly mapping to each other. And then identify as many number of paths as possible, but make sure every one of them should be definition because we don't say no here. Though with the statement put something like is definition here, but we expect the answer is yes or no. but I haven't come across any of the table where we write no. So logically, it means we should identify those paths which are bound to the definition here, because this gives the indication of the DC table. So DC table, everything should be yes. So we are list and identify those paths which are bound to the definition here. But before that, make sure we of these three tables, everyone should be able to easily draw two tables. It should not be a problem. And if you can come up with a third table, great. As defined as many number of the paths as possible. So it's almost 12:05, so we can make it 12:20. I think we should be able to do in 15 minutes. Okay. Are we able to get the source code? A quick yes or no?
Yes, sir.
Okay, fine. Also, I'm mailing this doc file to Parth so that he can forward it to you. So you don't have much of the problem in understanding. Okay, because the file cannot be shared in a chat box. So I'm mailing this file to Parth and he will forward it onto the group. Okay, Parth?
Yes, sir.